All right, we studied arithmetic sequences. Now we're going to analyze geometric sequences. And let's just talk about what the difference is. With arithmetic, you were adding the same number to the previous number to get the next number. That difference was constant. Well, now we're going to have a common ratio between the numbers. So let me show you how that works. Tell whether the sequence is geometric. So is the sequence between numbers, is the ratio between numbers the same? So you have to create the ratio. So I'll always take the current number, put it in the denominator, and put the next number in the numerator. So 10 over 4. I'll take the next ones. 18 over 10. 28 over 18. 40 over 28. And see if all those are identical. So the first one's 5 halves. All right, 5 halves. Second one is 9/5. So already these aren't the same. So that is not geometric. That's no, does not work. Let's try a letter B here. So I'll do 125 over 625, 25 over 125, 5 over 25, 1 over 5. I'm going to work from right to left because it'll simplify easier for me. 1/5 is the first one on the right. 5 over 25, divide both by 5, I get 1/5, all right? 25 and 125, divide both by 25, I get 1/5. I'm feeling pretty good about this. And the first one, divide both by 125, I get 1/5. So that one is geometric. All of them have the same ratio. All right, so it says, tell whether these are going forward. I'll do a couple more with you. Again, 27 over 81. Now you recognize these numbers. We've been through these 3 to the nth power. So these might be a little easier for you. 9 over 27, 3 over 9, 1 over 3. Again, working from right to left. 1/3, yep. 3 over 9, 1/3, yep. Divide 9 and 27 by 9, 1/3, sure. And 27, 81, 27 goes in both, 1/3. So that's yes. Let's try number 2. So I got 2 over 1, 6 over 2. Now I'm going to stop right there. 2 over 1, 6 over 2. Yeah, no. It's 2 and 3, right? Not the same number. So you get the idea how this works. Now, as with arithmetic, we have a rule. It's always the same rule. There it is. The nth number, okay, equal to the original first number times the rate of change, SAR, to the n minus 1 power. And we'll be doing like we did with arithmetic, where we're going to create the rule, A, and then given some random number in the list and the rate, can we come up with a rule also. Again, anytime you're doing the rule, folks, one of the main things you got to do here is you must get this A1. And you must have the rate also. Okay? All right, here we go. Let's try one. All right, red rule for the nth term. So, oops, I'll get that rule in here. It takes me a while to get memorized. So a to the n is, so it's an equal to the first number for this letter A, it's 4 times, now the rate is times 5 times 5. See, it's times 5 going away, so 5 n minus 1. There you go. What you're trying to find, folks, every time are these two things, the A1 and the R. All right, next one. 152. Looks like we're dividing by 2, by negative 2. Yeah, we're going to divide by negative 2 going here. So A of n equals the first number, 152. The rate is negative 2. We're dividing by negative 2. N minus 1. Of course, when it's an even number, when this becomes an even number, the sign, that's why the signs change. When it's even, it'll be positive. When it's negative, when it's even, it'll be a positive number. When it's odd, it'll be negative. It's the time of year, folks. All right, last example. Similar to what we do with arithmetic, we're going to give you a number out there someplace in the sequence, and give you the rate of change, ratio, and then come up with the rule. So again, writing the basic rule here for you is n equals A1 times R n minus 1. So that's what we're trying to fill in. And we are trying to get our A1 and our R. Okay, so what do we got so far? Remember, as I said before, we have Three pieces of information. Here's our rate over here. Here's our AN number, and here's the actual N itself. So we use those three pieces of information. So the A of N is going to be 12 equals A1 we're trying to find times R, which is 2. N is 4 minus 1. All right, so 4 minus 1 is 3. So I'll go over here. 12 equals A1 times 2 to the third power. Well, you know that by now. We've been doing that since winter. It's 8. So 12 equals A1 times 8. Divide by 8. A1 is 1.5. A1 is equal to 1.5. Now you got to write the rule, folks. All the way back to the left. It's going to be A of N equals 1.5 times 2 N minus 1. There's your rule for that. Again, every time you need to make sure you have your A1 and your R. And that's how that works. Let's see if I can do one more for you here. It's going to be simple. I'll try number 5 here, sure. Again, the basic rule again, so I have it in front of us, is AN equals A1 times R N minus 1. So in this problem, we're given the N, the A of N, and the R. And we're trying to find A1. So I'm going to plug those in. So A of N is going to be negative 96 equals A1 we're trying to find. R we have is 2. N is 6. So 6 minus 1. So it's negative 96 equals A1 times 2. 6 minus 1 is 5. That's going to be 32 if I recall. So we have negative 96 equals A1 times 32. I divide both sides by 32. A1 equals negative 3. Now, that's just A1. I got to write the rule. So A of N equals negative 3. The R here is 2. N minus 1. That is the actual rule. Alrighty, folks, good luck.